Well, exothermic and endothermic reactions. An exothermic reaction releases energy or releases heat. And so it's convenient in terms of equilibrium to think of heat as a product. An exothermic reaction produces heat, right? So then when we talk about changing the temperature, if we're increasing the temperature, that's like adding heat. If we add a product, the equilibrium will shift to the left, to the reactants. In an endothermic reaction, we can think of heat as being a reactant because we have to put heat in, put heat in to make the reaction go. And so changing the temperature will cause us to either increase or decrease the amount of heat. If we increase the temperature, that's like adding heat to the reactant side, it will cause the reaction to shift to the right. So here we have an exothermic reaction. So we think of heat as a product. If we add heat, the equilibrium shifts away from it. If we remove heat, if we cause the reaction mixture to be colder, it's saying you took my heat away, I'm going to shift this way to make more. It's like in your face, right? It's like you can't make me change. Endothermic reaction, think of heat as a reactant. So if we add heat, if we increase the temperature, the reaction will shift towards the right to undo what we did to it. If we remove heat by removing the temperature, it'll shift to the left. This is a very cool experiment that I wish we had one of these tubes so I could bring this in and show it to you. So the cool thing about this reaction is it is an endothermic reaction as written. The N2O4 is a colorless gas and NO2 is a brown gas. And so we can actually see a change. So here we have this tube filled with this mixture at equilibrium in a warm environment. And the warm environment favors the products. Because there's more heat, it favors the products. If we take that then and out of its warm environment and put it into ice and cool it down, we've removed heat, we're taking away one of the reactants, the reaction shifts toward the reactants and we see that it seemingly magically becomes clear. And you take that tube and you put it back and forth and it'll just change colors back and forth. The effect of temperature on an equilibrium. So summary is there. Let's do an example. We looked at this one already. Now we're saying this one is exothermic. So what I want to do before I even look at the question is this is exothermic. That tells me that heat is produced. It's a product. So write that in there and then look at the question. What's the effect of increasing the temperature? So I'm increasing the amount of heat. What's the reaction do? It's going to shift away to get rid of it. It'll shift to the left. What if I decrease the heat? If I take heat away, it'll shift towards that to replace it. That make sense?